For question 1, suppose you mix 2 liters of a 15% acid solution with 4 liters of a 50% acid solution. What is the concentration of acid in the final mixture? Well, it should be something between 15% and 50%. So to approach this problem, I'm first going to define my variable x as the concentration of acid in the final mixture. So maybe I'll make a note that, okay, it's got to be a percent when I record it. When I set up my equation, it's going to be on one side what I'm mixing and on the other what I end up with. So starting with what I'm mixing together, I'm taking 15% of something that is 2 liters. I'm going to write that as 0.15 times 2. That's the amount of acid in that solution. So I'm mixing in, I'm going to add to that 4 liters of something that is 50% acid. So the amount of acid is 50% times the 4 liters. That's the amount of acid that's being mixed together. And what I end up with is one solution. Notice it's always the percent times the amount, the percent times the amount. And the reason we have 2 of those terms is because we're mixing 2 things together. In our final solution, I should just have one term, some percent times some amount. Well, the percent is precisely the thing that I do not know. I'll leave that as x. And next to it in parentheses is going to be the amount of liquid that you have. Well, if we have 2 liters and 4 liters being mixed together, you could put 6, but maybe just to illustrate this, you're adding those 2 amounts together. I think it's at this point where we could now solve this equation pretty easily for x. All right, let's see. 0.15 times 2 is 0.3, plus 0.5 times 4 is 2. And I'm going to set that equal to, well, I already said that 2 and 4 is 6, and 6 times x is 6x. So to combine this, on the left, 2 and 0.3 is 2.3. And to solve for x, I will simply divide both sides by 6. And okay, on my calculator, when I do that, let me see here. Okay, I'm getting 0.383. It's going on forever, so I'm going to round it to 3 decimal places. So I'll write this as my answer. Now this should be a percent, so what I'm going to do is convert my answer to a percentage by multiplying by 100. And this means my final answer is 38.3%. And this makes sense. I was expecting the answer to be between 15 and 50%. But furthermore, I also thought the answer would be closer to 50% than 15% because I have more of this stuff. So the answer makes sense, and that's it for the first question. For the second question, a similar idea, but I'm not looking for a percent this time. How many ounces of a 5% acid solution must you mix with 10 ounces of a 25% acid solution in order to decrease the concentration of acid to 10%? So this makes sense. You're starting with 10 ounces of this percentage. If you pour in something that's 5%, it'll certainly lower it. So there must be some exact amount that would take you to something that's 10%. I'm going to start again by defining my variable, which I'm going to call x. But this time, it's the number of ounces, which you could abbreviate if you want. It's ounces of the 5% acid solution. So there's like a note to myself. That's what I'm solving for. How much of that stuff am I going to pour in? Now, even though the variable is representing something different, the idea in the equation, the way we set this up, is going to be exactly the same. So I'm going to start by, let's see, I have some number of ounces of something that's 5% acid. So when I express that, it's going to be 5%, which is 0.05, but it's going to be multiplied by x. To that, I'm going to add, okay, I have 10 ounces of something that's 25% acid. So in this example, the variable, it's not a percentage, but it's an actual amount of something that you're pouring in. Again, we have 2 terms because we're mixing 2 things together. On the other side of my equation, I'm just going to have one term, a percent times an amount? Well, I know I want it to be 10%, so I'm going to put in 0.10. And the amount of liquid that we have, well, in the previous question, we just added the two together and got 6. Here, when you add x and 10, well, you can't take it any further than calling it x plus 10. So it's that amount, whatever it is, times 10%. And I now want to solve this equation for x. So let's see. On the left, I get 0.05x. 0.25 times 10 is 2.5. And on the right, I have to distribute in the 0.1 to both terms. That gives me 0.1x, and 10 times 0.1 is 1. Okay, I can't combine any terms, but I think what I'll do is subtract 1 from both sides. This gives me 0.05x plus 1.5 is equal to 0.1x. I will now subtract 0.05x from both sides. And this results in 1.5 is equal to 0.05x. I will divide both sides by the number in front of x, which is 0.05. And again, I'll do this on a calculator, although I think you probably could do this one in your head if you'd like. Actually, yeah, this one's going to be 30. So that means we are going to, let me put that answer over here. You'd have to pour in 30 ounces of the 5% acid solution to decrease the original one from 25% down to 10%. To graph the equation of the line y equals x plus 4, we can set up a table and choose some x values. So what we'll do is pick some numbers for x. You can choose any numbers you'd like, but it's pretty standard to go -2, -1, 0, 1, and 2. We'll take these values for x, put them in place of this equation, and solve for the corresponding y values. This will allow us to plot these points. So I'll start with -2. If we put -2 in place of this x, you're going to take -2 and add 4, which gives us +2. So I'll put that process over here. The y value is -2 plus 4, resulting in +2. For the remaining points, the next one would be, okay, I'll put -1 in place of x and add 4, so I get 3. 0 would go in place of x, you'd add 4, you get 4. Putting 1 in place of x yields 5, and then 2 in place of x will give us 6. So if I try to graph all of these points, I'm going to start with the point -2, 2. So that is -2 for x and 2 for y. The next point is -1, 3. So -1 for x and 3 for y would go right there. 0, 4. I'll just place that 1 at this point here. 1 for x, 5 for y, 2 for x, and 6 for y. And we have these points here. And really, once you have enough points to see a pattern, that's enough to give us the sketch that we want. It looks to me like the equation, I'll put that in red, is the line that's going between these points. So this is a sketch of my graph. Okay, we're also asked to determine the slope and the y-intercept of this line. The y-intercept is the place where the graph crosses the y-axis, and that's this spot right here. That is the point 0 for x and 4 for y. So I'll mark that off to the side. I can just look at the graph and note that the y-intercept is the point 0, 4. Another easy thing to determine is the slope. Slope roughly is defined as the rise over the run. Rise means how far are you going up, and the run means how far are you going across. So if you examine that, like you could look at this point here. You go over 1 and up 1, and you land back on the line. And this is true for any point that you choose. You go over 1 and up 1, over 1, up 1, over 1, up 1. The slope of this line, using that definition, would be 1 over 1. The run is go over 1. The rise is go up 1. And more simply, you could just say that the slope is equal to 1. In question 4, I want to determine the slope and y-intercept of the line that's given below. So here we're actually given the graph of the line, and from it, can we figure out the y-intercept as well as the slope? So it looks like the y-intercept is exactly the same as the one in the previous question. I'm just getting this directly off of the graph. The y-intercept is also at 0, 4. 0 for x and 4 for y. What is definitely different this time is the slope. To determine the slope, which I'm saying is the rise over the run, you can pick any point that you like on the graph. I mean, we could use this one right here. And we want to see how far over, and then in this case, down we go until we end up on the line again. So you can use any other point that you would like. So I'm just going to pick a second one. It doesn't matter. I'm going to use this point here. Okay, the run is how far across you go. So that's 2. I'm going to mark that in my slope. The slope is, well, I know the run is 2. So you go over 2. Now, because we're going down instead of up, we're going to use a negative number to indicate that we're moving downward. But from this point here, we're going down 4 places. So that means the rise is actually -4. And you could call this the slope if you'd like. There's nothing wrong with that. But this is a fraction, and you can reduce it too. -4 divided by 2 is the same thing as -2, or if you'd like, -2 over 1. So, examining this just a little bit differently, if you go over 1 and down 2, you also end up on the line again. And this is what slope is trying to tell us. No matter what point you pick, let's see this one. If I go over 2 and down 4, you end up on the line again. Or if you went over 1 and down 2, again, we're ending up on the line. This holds true for any pair of points that you choose. The last thing to note is that in question 3, the slope was 1 and the graph was moving upward. In question 4, the slope was negative and the graph is moving downward. So slope tells you, is your line increasing or is it decreasing? And a little bit more, the slope here was 1 and was increasing this amount. If the slope was like 2 or 3, it would be steeper. So not only does it tell you is the graph going up or down, but how steep it's going to be.